exactly at 4. I'll take it from there. All right, cool. Okay, I guess we can begin. All right, so good afternoon, everybody, and welcome to our 4th installment of the Data Powered webinar series. This is a series where we try through real-world examples to spark your imaginations on how you can use data and data-related technologies to improve your productivity and efficiency in your organizations. All right, my name is Kailash Maharaj. Well, not today, it was always Kailash Maharaj, and I will be your presenter. So I am the CEO of Intelligent Applications. We are a local Trinidad and Tobago company that deals mainly in software development and data analytics. We're going to talk about the Agile and DevOps process, a process that we use in both areas of specialty. So to kick off, so first of all, let me just say that I love to code. It has always been a big passion of mine since I was a kid. And the 14-year-old version of me would have spent a good Saturday afternoon trying to do this on his Commodore 64 computer. I really do love it. And I'm not the only one. A good friend of mine just wrote me today and told me that in 1984, today was the first day he wrote his first line of code. If you could remember those things, you definitely have to have a passion for these things. And just by the way, you will be able to listen to that person next week. I was lucky enough that I got a profession in coding, right? And that was also in Europe. Now, as much as I do love coding, and it can be very stressful, right? Anybody who has programmed, if you have not reached this state, then you haven't really been doing coding, right? All of us have been there. And a big part of the reason why it gets stressful is I believe there's a big misconception when it comes to software development about the time and effort that is required to do software. And let me just demonstrate by some statistics, right? These are some statistics that I got off the internet, and I could post the link below so you all could take a look at it for yourselves. But basically, a simple software project requires about 500 hours, dev hours. 500 hours roughly translates to about 3.5 months. And that is a lot of time people may think for a simple project, but that's what the average time it takes. The average budget for that size project is between 50 to 70K USD, right? I'm even talking Trinidad and Tobago dollars here. And then a more complex medium-sized version of an application goes upwards of 1,200 hours. Now, the problem is that most clients, and this does translate to what we've seen down here, most clients have medium complexity projects, but they expect to do that within a 500-hour time frame. And not only that, they're not willing to pay about half or a third of the cost for a simple project. And under those constraints, you can imagine that it can create a lot of false expectations. And again, further statistics to show that is that today, 14% of software projects end up in a catastrophe, meaning they're absolutely canceled, done, finished, given up on, right? And that's a large part. 31% don't meet their targets, and by don't meet their targets, basically what most of them project finishes and they're shelved, never really used to what they're designed for. And 43% exceed budgets. And by all accounts, this is a lot better than it was 20 years ago. The statistics were much higher, but there's a lot of room for improvement. Right? And where could we find that improvement? Now, when you're developing software, there are three main components to that, right? There's the technology, right? The sort of technology that you use to develop the software, right? To build the final software. And there's also the people aspect, your developers, but not just your developers. We're also talking about your end users as well, because they play a key role in your software development process. And the glue or the one that turns both of them or gets them to interact in a very productive way is your process. And this is what we're going to look at today. Some of the processes in software development and one of the tools that we have been using this past year to help us along those processes. Now, software development has come a long way, right? Some of these represents the three main philosophies of software development since its inception. We have the waterfall model. This was followed by the agile model, and then most recently the DevOps model. The software model was born around the 1970s. Now, software, as in programmable computers and writing programs to make a computer do what it wants, sort of started in the 1950s, late 1950s. And through the 1950s to the early 70s, people just built code. Yeah, I couldn't find anything that there was a process around it. They just built code. Now, remarkably, during that time, they did send they write programs to send men to the moon. But there's a big difference there, right? The thing is, at that point in time, the US was in big competition with the Soviet Union to sort of win the space race. And therefore, the people who were writing code for that project, for that NASA project, probably had quote unquote unlimited resources. They would spare no expense to make sure that that was done. But that in real world projects, companies don't have that kind of budget. So a lot of projects that were not related to the national projects, ran into problems, and people decided, well, they need some sort of process to follow. So they borrowed very much from the engineering field, and this is where they came up with the waterfall model. And let's talk a little bit about the waterfall model. Now, the waterfall model has pretty defined stages, and you do not move from one stage to another until you have completed that stage. And this is why it's sort of called a waterfall model, because you can cascade from one stage down to the next stage, and finally to the final stage. The waterfall model did bring a sort of structure to software development, and it probably is better than having absolutely no process. But there were a lot of shortcomings with the waterfall model. right? And for those of you who are practitioners of software development, you would know them. The thing is, before a customer starts seeing the product, the final product, which is down in the testing or in the testing deployment phase, right? A lot of time would have passed. Sometimes months would have passed. And if they discovered that something was wrong or they needed some change, it was very expensive to go back to the beginning and try and redo all of that. And there was also, because it was structured like this, there was very little interaction between the customer and the developers and the development team, which meant quite often or not, you fell into that the wrong software was being built. It didn't meet what they really needed to do, and all these sorts of issues, which brought about, which sort of screamed for a change in approach to software development. And that actually took place around the early 2000s. And I remember when the Agile philosophy came out and they wrote the Agile manifesto and so forth, and all the developers was like, yes, this is what we needed, because that philosophy tried to correct many of the shortcomings that we saw with the waterfall model. And what it tried to do, it tried to make sure that you get working software in front of your client very quickly. And what that meant was that very early on, in early stages in the project, clients were able to validate and verify what was being built. You were able to track, make sure that you were on track with the requirements, or if they had changes, they could have brought it up early on in the project and thus lead the way to developing the sort of app that the client really needed. And I think this part is particularly important. Software development, and as the explosion of the power of computing got bigger, the demand for the types of software to be written also got bigger and increase in complexity. And when you're developing complex systems, it is very difficult for you to envision at the very beginning or foresee all the issues that you may encounter. Most teams would have done the analysis and they would have in their heads, yeah, this is what we really think it should be. But it's only when you make that into concrete software that it can test and use, you start seeing things a lot differently. It clashes with the real world and you start to say, oh, maybe I need to do this in a certain way. That way wouldn't work. Or I didn't realize that these interactions would cause this problem and we now have to tackle that. And all these things, by putting working software in front of the client, it addressed those risks that you could try to catch early on the project and tackle them early so that you got rid of those risks and eventually be able to develop successful projects. Now, there's a caveat here, is that Agile, as it was initially written, there are the purists who claim that you should just don't worry to do too much requirements, just get the basic requirements and start developing software. And those who followed those very strict guidelines, again, ran into very problems because that is not how the real world works, right? The philosophy tends to lend itself to continuous deployment of software, but clients have very real world problems and they have very fixed budgets and fixed deadlines. And the tendency to continuously, with constant feedback, was to try and change things. And again, you would get stretched timelines, going over budget, and running up costs. So there's a certain level of where you have to mix the best practices with Agile, with some things that you do from the waterfall model, right? Like, for example, right now, we make sure that our requirements model, we do our requirements in almost a waterfall way, meaning that we try to get as much as we can upfront before we start any development, because we have seen just kicking off your project on minimum requirements would lead to a lot of rework and misconceptions and those are stretch timelines further down the road. Then within recent years, this whole idea of a new way of DevOps came into being. And what DevOps stressed on was that you not only need to take into consideration your development, but how you deploy your solution as well. And that's where the operations there refers to deploying your solutions into the real world. Now, honestly, if you go and look at the literature right now, they would give you a lot of differences between what DevOps is and from Agile. But in my view, I don't think it is philosophically different than Agile. Because in all my years of programming and being on different projects, we always took into consideration how you had to deploy your solution. I think what has changed though is that some of the tools for easing the deployment, so continuous integration, continuous deployment, automated testing has improved significantly over the years. And so there's that aspect that it makes it a lot easier if you follow certain guidelines and best practices. You can deploy to your solution a lot easier and save a lot of time. But philosophically, it is much more the Agile, just with better tools. What observing these different philosophies over the years, and I take this quote from Butley, is that, you know, to follow any one rigidly, you will run into problems, because the real world is much different than any one sort of approach can handle. And what you really have to do is sort of understand the situation that you're in and develop a model which works for you and your team and your client. And that model will tend to be generally the best practices of all the approaches we have seen so far. So you have to mix and match to suit you. And for us, and what we have seen is that our philosophy is generally based on Agile, the Agile philosophy, because it works well. I do believe that getting a working solution, which is the only measurable way of measuring progress on a software in front of your clients, works wonders. But there are other things that you have to balance in doing that, right? And one of the tools that we have seen quite recently that helps us with our process is Azure DevOps. After Power BI, I think this was one of the tools that as soon as we started using it, you know, you were awed. Wow, this really works for us. This brings a new level of process improvement. And the reason is, so what Azure DevOps does, right? Of course, it takes the DevOps philosophy, but it's an amalgamation of several different tools on the Azure platform, which you do not have to use all of them. You can just pick the ones that you need for your particular process and use it. And the thing is, you can pick any one of them and they will easily integrate with the other sort of tools, right? This is what it looks like in the application, right? And you see this board that we're showing here. I think this was sort of one of the biggest revelations for us. And let me explain. It's almost like having a dashboard. You know, before this, we were using other tools where it was sort of list-based, like looking at a Excel data sheet, you see multiple rows, and yes, you can use it, but when you have lots and lots of rows of data, you know, it's very hard for you to visualize what is actually going on. And like just as a dashboard would take your data and summarize it for you in a view that you could instantly understand and see how things are going, so too does this sort of layout do that for us. You know, we at the top here, we can say which sort of swim lanes that we want, representing the different stages of our process. And we have the cards that represent our user stories, telling us exactly, you know, how much we have in each lane and the status there is. And speaking to Yajesh, who's our project manager, you know, he said after using this, he can't go back to the the list-based programs, because this brings another level of vision to your project that you just cannot get from the others. And this is just one of the main features, right? Some of the things that we really liked about the DevOps, and this is from a technical point of view, well, the task navigation, and that's what we were speaking about here. Not only that you see it from a high level, but from a user point of view, they are able to see what tasks are assigned to them, what tasks depend on them, what tasks they depend on, what tasks they are related to, what is the status, and the entire thread, because usually, you know, some user stories evolve as time goes on. They can see the entire thread of what was, how that user stories it changed or was verified or was cleared up. All that is in there, and that again, tremendous improvement in productivity. Another great productivity is the branch management. We're all familiar with, you know, code repositories and so forth, but branch management, and just to give an idea of what a branch is that when you release a certain version of code into your test or production environment, you know, you have a certain version there. Now, when you release that, sometimes you have to go on and work on other items, other features. If you start doing that, so let's say you start working on another feature, but then something happens in production and you have to go back and fix a bug there. You know, you don't want to take your current code that you're working on, undo everything that you did, and then go back and correct the error, or try to correct the error in your current code and therefore send a bunch of code that you have not tested to in production. What you do is you create a duplicate of your code from the last version that you have in your production environment, which is called your branch. You correct it there and redeploy it, you know, minimizing any risk of further errors. And those sort of things you wouldn't believe. Azure helps us to do that so easily and seamlessly that again, it improves our productivity quite a lot. Other areas sometimes helps a lot with code reviews, and as we spoke of earlier, the tools for continuous integration, meaning when you, as you finish check-in, you know, it's checked into the main branch and compiled, and you have automated testing to support all of that. So there's a lot of features in there that has just brought about a great deal of productivity for the developers. For the project management side of things, you have a tremendous amount of increase in collaboration. So right now, we use our DevOps in our Scrum meetings. Again, for those of you who may not be aware, the Scrum meeting is one of those great best practices. We came out of the Agile movement, where we meet for about 15 minutes to half an hour every day to sort of plan out what it is we're going to do for the day, right? And everybody, again, could be looking at this, especially now that everybody's working in, you know, remote forms, looking at the same board, understanding what their tasks are. Immediately they could say who's depending on, and managing, you know, what it is your workload going to look like for the day from here. We also have a Scrum at the end of the day where we close off certain items and make sure that the board is always updated. Again, great for productivity, great for project managers. They always are up to date with the exact status of where everything is. And just to fall back, again, you know, Scrum ideally supposed to be a stand-up meeting, 15 minutes and everybody stayed, but we just have found that combining driving that process through DevOps, taking a little bit longer to understand, just makes everything run a lot smoother. Facilitates faster deployment, again, because you're managing your branches correctly, your versions correctly, everybody know what is happening. You can deploy a lot faster, especially with the continuous integration and deployment tools. Overall, again, because of its usability, it improves your quality management through testing and just making sure that everybody's on the same page and have access to the information that they need to work properly. And again, as with dashboards, it improves transparency and accountability, right? Because because everybody is looking at, you can't hide behind where you are at with your process, right? With your particular task, you have to come clean, and everybody knows, if you're having challenges or where we are exactly at any point in time. Now, if you haven't done so and you're new to this, it will help you promote your continuous delivery, which is all part of the Agile process. So DevOps has really given us a really big boost in terms of being a tool that we could use to help drive our own process. And again, we have our own process that we mix and match from the other philosophies, and we were able to, use DevOps to sort of lay that out and then drive that from there. So a fantastic tool, highly recommended. I know our time is short, so for those of you who would like to have a demo of DevOps, you can please message us in the various chats, whether you're on YouTube or right now we're going to post a feedback form. Please take a few minutes and let us know how we can improve the delivery of our presentation and what other things you would like to see in the future. And if you would like to see a presentation DevOps, we can certainly organize to do so. So that is my presentation today. I would like to just close it off here and open to the floor for any questions and comments or questions from the audience.
We have some questions from YouTube. I just pasted them in chat so you can see it if you need to go over it.
Right.
It's from Roberto. And it's which process template do you use in Azure DevOps? And what's the branching model use for pull requests?
Okay, maybe I would just like to pass, maybe Mitra or Yajesh can say.
Hey, Kailash, we usually use the Agile templates. We don't always use the default setups. Sometimes we go in there and modify the templates to suit how we work within the organization. But we usually find using the Agile template is a good starter point.
All right, cool. And Mitra, you could answer the one about the branching model and pull requests. Well, we do use pull requests, I know that for sure.
Yeah, so how we normally do our code, we create separate branch, one for production, one for kind of staging environment, one for development. And of development, we would create a small minor branch for basic features. And once a feature is completed, those guys will just create a pull request from that feature branch back into development. But on that pull request now, we will do our code reviews to make sure everything is aligned to what we wanted before it merged back in development. And once it is in development, we would just push it out, maybe our dev server to run our QA tests and stuff internally, and then we'll keep moving it up. It does answer your question, Roberto.
So I know YouTube have a slight delay, so it might take him a little bit. Okay. But in the meantime, does anybody else have any other questions? You could post it in the chat here. You could raise your hand and we can make you a presenter so that you can ask any questions you have. We have another comment on YouTube. I don't believe this is a question, but I'll just paste it in chat so you can see it here one time. Right, and this is from Sham saying that they use the boards to manage 2-week sprints and found that they underestimate the task that needs managed and it pushes into other sprints. So
Again,
I guess maybe some advice on that.
right. So I think from our experience, so that's such a typical problem. Estimating is one of those very, very hard problems that in software development is very hard to estimate. So we have found, at least from our experience, 3-week sprints are usually the best. And I would like to probably invite Yajesh or Mitra to talk a little more about those because they have been driving those sprint process for this past couple of years. You guys can talk about it, Yajesh?
Yeah, Kailash, sure. So yeah, as Kailash mentioned, we typically try to use 3-week sprints at the beginning of projects. Sometimes we may alter to a 2-week sprint or even a 1-week sprint, depending on the activities that we have to get done. Now, learning from experience, there's hardly ever a time that we actually complete everything that we set out to do in the sprint. And that is something that's known as part of following the Agile framework and the iterative methodology. Now, some of the practices we started implementing to try to get a bit closer to achieving the targets for the sprint is actually from the beginning looking at the resources that we have available, and then after resourcing, looking at the resources we have available, we look at what time or capacity that the resources have to work on the project. So we start with having that baseline estimation of capacity. Once we have the baseline estimation for capacity, we then start thinking, how do we break down this capacity? Is it just that these persons will be working on development for this project, and how much productive hours they'll actually have available to work on for development? Now, this part starts to get a little more detailed because you could have a developer who is available for 8 hours in the day, but those 8 hours likely will not be 8 productive hours. So for example, we'll create a user story and we know what this requirement is, and we start breaking down the user story into smaller tasks, manageable tasks, and we try to keep our tasks down to 3 hours. So we break it down really, really small. And once we have this now, what we will not do is say, okay, so today the person has 8 hours in capacity. We won't give them 2.5 tasks to work on to fill up that entire 8 hours. Once we start filling up our resources capacity in that way, we have always learned from experience. Delays come up because it's software development. You might encounter a bug, or during development, you'll find that you don't have enough information at hand to complete it 100%. So a question will pop up and you'll sync with your project manager and you'll want to reach out to your customer and have a quick discussion and progress things again. So again, this is the whole concept of being agile and being flexible. But going back to actually trying to keep close within your targets for a 2-week sprint, it's not thinking that, okay, I have one developer available for these 2 weeks, 8 hours per day, and I'll make sure that all the tasks I have fills up all of his time. All right. The first part is trying to actually estimate what productive hours this developer could achieve in a day. I found that trying to estimate a certain amount of time for development, a certain amount of time for testing, and a certain amount of time for bugs will give you a better estimation of how much they could actually achieve in a day. So for example, you might want to, and this all depends on the expertise of your developer, the technologies they're using. If it's something totally new that they're going to be working on, all of these things need to be taken into consideration. For routine things, these estimates or these considerations will be different, or for more complex implementations, it will be different. Let's say for routine things, you might want to consider, let's give this developer hour leeway for doing testing, hour and a half leeway doing testing. Let's cater that he'll probably need to have an hour and a half if he was to bounce up any bugs or any questions that he might have during the process. And they will start realizing, oh, wow, I just opened up a lot more space if delays were to occur during a day or during a week. If you plan your timelines too tight, the slightest issue that pops up, the slightest question that pops up, you basically start running late. Now, I think it's Sham. He didn't exactly say what challenges he faces because the 2-week sprints push over and the items push over into another sprint. But many times, what we realize as well, a challenge you'll face here is that the customer is expecting something at the end of that 2 weeks or at the end of that 3 weeks. And that's one challenge you start finding. The customer expectation is that they'll be getting this working version that they want to start seeing and testing. And when we start experiencing delays, you maybe start becoming stressed. You feel like you're going to disappoint the customer. One of the things that Agile tries to push is talk to your customers on a daily basis. So as much as you need to, and you start realizing that even in this time period where the scope might have you might have some scope creep because something wasn't thought of before, a certain process wasn't mentioned, and you need to take different things into consideration now, and your estimates start to increase. Your customer is aware throughout the entire process. So if things start to go off track, you could keep them in the loop as soon as these things happen. So at the end of the 2 weeks, you don't go back to say, we only got half or a quarter of the work done. And then you have miscommunication and misalignment. So that's just some of it. There's a lot of it that goes into it. But these are just some of the tips and tricks that we found useful for trying to keep the sprint plan in check.
Right. Thanks, Yujish. So Sham said that he didn't know that they could make the sprints 3 weeks. So I think if you're using Azure DevOps, you could adjust the timeline of the sprints. Right. So that's one thing. And the second thing is that it was a very interesting perspective that was helpful. They're using a new system to break down tasks into 3-hour pieces, which would make the proper allocation of resources. So that is something that we also try to do, break down the task into small pieces. I would say not necessarily to break down your task into 3-hour pieces, but break it down as small as reasonably you could. Right? Because even if you have 1 hour or 2-hour tasks, that would help with the underestimation of the tasks. I'm not sure if you want to follow up anything there, Jish. Otherwise, we could go back to you, Kailash.
Nothing further from my side, Ismail. That was good commentary.
All right. I don't know if Sham meant that he didn't realize in DevOps you could do 3-week sprints, but in general, I know just extrapolate a little bit is that, when you're introduced to new philosophies and new things, initially you want to do everything exactly the way they said it should be done. But with experience, you would see that, it is very rare that one particular way of doing something will match your real world situation. So always try to draw on your experience, what your situation is. If you have best practices that you have known that worked for you in the past, see how you could mix and match those best practices to create something that works for you. Right? Ismi, there's another question.
No more questions at the moment. Sham just said that they don't use it for software development, but for many projects, which shows how robust and diverse DevOps could be. So even in breaking down a task and stuff, you try to break it down as much as possible and stuff like that.
Yes, and like we said before, we've been using it on our data projects as well, because as a sort of project management tool, especially with technology-based projects, it does a really good job. All right, so I know it's now 4:38. If there are no other questions, any more questions, anyone?
No further questions on YouTube. Just have thanks from Roberto and Sham, and yeah, guess that's it.
Okay, all right. Just a reminder again, if you can please, I don't know if we could post it up also on the YouTube, as we've been getting questions through there, the feedback form. And if Roberto and Sham could just please it's less than a minute to give us some feedback so we know how to make improvements for the next time. So that's it from us today. We do look forward to next week when we have a pretty exciting session for you all. Especially, it's going to be a little more technical, but as technical as it is, it can benefit the business user. So look forward to that next week, and to close up this year with our data powered series. And from the feedback, we hopefully get started again sometime next year. All right, everybody, take care, and thank you very much for joining us today.